Objective 4 is to find graph features algebraically of a quadratic function from vertex form. All right. So we just worked through standard form. If given a function in standard form, can we find specific graph features? More specifically, whether or not it's positive or negative, open up or down, max or min, axis of symmetry, vertex, y-intercepts, x-intercepts, kind of, and domain and range. So we're going to do similar things with the vertex form. All right. Now, vertex form. Mainly, all I really care about with vertex form is that you can recognize what the vertex is. We'll still be able to fill in some pieces of this information over here, but mainly I want you to be able to tell me what the vertex is, and then later on in this module we're gonna be able to graph these very specifically. So then, based off of drawing them very nicely, you'll be able to find the y-intercept, x-intercepts, and such like that. So. Vertex form is given to you as y equals a times x minus h plus k. And I do need to erase that. It says it in the name. This actually gives you the vertex. So in this case, the vertex is always going to be your h and k value. And if you notice, h is in the position of the x, and k is in the position of the y. So that's your x and y value of the vertex. We're going to do the similar example over here, and so I've found the vertex. This is the problem I've been working with throughout these whole videos. I found the vertex already, so I can label it 1, 3. Now, specifically though, I want to talk about the vertex form of this standard form function, because it can be written in either way, vertex form or standard form. Let me label this. So this is A, this is B, this is C. So the vertex form of this standard form function is y equals a, and the a is the same, so 2 parentheses, x doesn't change, x minus whatever my x value of the vertex is, so x minus 1, and then it says plus k in the given function up here, y equals a times x minus h. Sorry, this is supposed to be squared too. Y equals a times x minus h squared plus k, but it could be plus or minus k, it doesn't matter. So in this case, my y is negative, so it becomes minus 3, so my k is negative 3. So this is vertex form of the same function, all right? If given in standard form, it's over here. Vertex form is over here. It is the same function, okay? The c value is still the same, negative 3. So if you notice, the y-intercept will still be 0, negative 3. So that's still the same as something we've always been working with. But vertex form is very specific and very convenient because if you're given a function in vertex form, you automatically know the vertex. That's why it's called vertex form. One thing I have to talk about, though, in this video, and then it'll be the completion of this video. Here's the power that exists, right, in vertex form. So, I'm sorry, I'm going to erase this and give myself a little bit more room. Squared minus 3. I needed to include that, this power of 2 right there. It's x minus h squared, all right? It's quadratic. Now, anything to the left, and this is, I've tried to help students remember this in a variety of different ways, but that Beyonce song, to the left, everything you own in a box, to the left. Beyonce is married to Jay-Z. There was rumors that Jay-Z cheated on her, so he lied to her potentially. And so anything to the left of the vertex is lying to, or anything left of the power of 2 is lying to you. So that song, you can sing it in your head if you want to the left, everything you own in a box to the left is lying to you. So if you notice, in the formula, or in the function 2 times x minus 1 squared minus 3, the h value here is lying to you. It's a negative 1 there, but from the vertex that we found, it's a positive 1. So if you're given a function, and the h value is a negative number, you know that the vertex has to be a positive number. That's the only rule with this. To the left is lying to you. So a number to the left of the quadratic, or of the power of 2, is lying to you. So it's a negative number in the function itself, positive number in the vertex. The k value doesn't change. It is telling the truth. It'll always be what it exists in the function. So if you're given vertex form of a function, you should be able to tell me straight through what the vertex is. 1 comma negative 3. Remembering that this value, it's a negative 1 in the function, but the h value is always lying to you. Alright? So if it's a negative, it needs to become positive in the vertex itself. And if you notice, if given the vertex, I was able to write out the function, but it was a positive 1 in vertex, so I have to put negative 1 in the actual function of vertex form. So by the end of this, if you're given a function, so let me go to here. It says to find the vertex. That's not what I want. It says to find the vertex. So example 1 here. The vertex is, this is the h value, this is the k value. The h value is negative 1 here, but it's lying to you. Anything to the left is lying to you. So the vertex is positive 1, comma, k is telling the truth, negative 4. So I can plot that 1, comma, negative 4. I know that it's opening down because of that negative 2, so it's looking something like that. And then from that picture, I'm able to find the domain and the range and what the y-intercept is and whether or not they have x-intercepts. But mainly from vertex form, all I care about is if you're given a function here, can you tell me the vertex from it, knowing that the h value is always lying to you? And a challenge problem will be, if you're given standard form, can you find the vertex and then write it in vertex form? So at this point, you can try that. You've already found the vertex for this piece in a different place in your packet. So if you found the vertex, can you write vertex form? So go ahead and try that, and then check your math with mine. Alright, so at this point you should have paused it, tried to find the vertex from this one, which you've already done that, so the vertex is 3, comma 7. Now, the hardest part about this is to write it in vertex form. I showed my answer over here. It's y equals a. In this case, a is negative 1. So y equals negative. I could put the 1, I don't need to. So y equals negative, parenthesis x, minus h. In this case, this is the x and y value. It's also the h and the k value. So the h value from the vertex is positive 3, but the h value is always lying to you when it goes from vertex into the function itself. So it was positive 3. I need to write x minus 3 squared and then plus 7. The k value is 7. It's positive 7. That's telling the truth. Another way to think about it is h in the formula is always opposite whatever it is from the vertex and vice versa. If h in the vertex, it's always opposite when traveling to the function. So, if you didn't get that for your answer, please raise your hand. I'll come talk to you about it. But now you're ready, and you can fill this in as you go, but you should have been doing that regardless. That knowledge should have been already there. Because if I'm given vertex form right here, I know that it's negative, so I know that it opens down. So that means it has a maximum. The axis is the vertex, it's given to me, so the vertex is 3, comma 7, which means the axis of symmetry is at x equals 3. And the y-intercept is at negative 7 because of that negative interacts with that 7, so it's 0, comma. But these pieces I care more about when you learn how to graph the graph exactly. Then you should be able to put all of this together and find it exactly. So, at this point, though, I can graph 3, comma 7 and know that it opens down, something like that. And then the domain is all real numbers, and the range is from negative infinity up to 7, which you should have already done. So at this point, you should be able to work through this practice. Finding the vertex, finding the axis of symmetry, state if it'll open up or down, has a max or min, sketch a graph, and then state the domain and range.